This video will be about circles and arcs. So when you're looking at a circle, all the different pieces can be called, when I say pieces, I should be a little more specific. These pieces on the outside, if we just want part of the outside of a circle, this is called an arc. And when you name an arc, you use the starting letter and the ending letter, so BC, and you put what looks like a little arc above it to say, hey, this is an arc. And if the arc is less than 180 degrees, it is called a minor arc. You could also take an arc that's more than 180 degrees, and this would be called a major arc. Now the problem with a major arc is I start and stop at the same letters. I could say, well, hey, I start at B and I end at C. But that's what we already called our minor arc. It's always assumed if there's just two letters, you're going for the shortest distance between those two letters. If it's a major arc, you've got to use three letters, so I could call this BAC. I still have to use the start and the finish, but I can use any of the middle letters, so I could say BDC. So BDC or BAC, I could call that our major arc. And a special kind of arc is when you use exactly half of the circle. That's called a semicircle. So when you do that, that's 180 degrees because it's half the circle. An entire circle is 360, so half would be 180. And it has to be formed using a diameter, a line that goes all the way across the circle through the center point. And it also needs three letters. So this is a semicircle. Now these arcs can have angle measures. Here we have a central angle. That is an angle going through the center of the circle. And my handwriting is kind of poor. I meant for that to be 130 degrees, 130 degrees. So AED is a central angle, and it has an arc that goes with it. We started at A, ended at D. We want the arc that goes from A to D. That arc is considered to have the same angle measure as the central angle it corresponds to. So arc AD is also 130 degrees. And usually they'll put a little M in front to indicate you're finding the angle measure of the arc. We could also actually find the arc measure of CD, even though they haven't labeled what that angle measure is. Connected from A to C is a straight line, and straight lines, just like semicircles, have an angle measure of 180 degrees. Well, we can use this information to find the angle measure of the central angle here in the red question mark. So we're going to take the entire angle measure from start to finish is 180 degrees, and we want to get rid of this 130 piece. So when you're trying to get rid of something, you're going to subtract. So the measure of CD will correspond to that central angle, which we're going to find by doing 180 minus 130. So that means the measure of CD is 50 degrees. Another way that we can find our central angles or our arcs that go with those central angles is they can just give us a percentage of the circle. So they want Snickers and Twix. That would be this piece of the circle right here. So together that is 32% of the circle. 25 plus 7 will give us 32% of the circle. So if we want to know the measure of the angle, we know an entire circle is 360 degrees. And we just have to multiply it by the percentage that we're actually looking at. 32%, if we want to work with it, it needs to be a decimal. So we're going to change it to be 0.32. 32%, the decimal, if it's not written, is on the end of the number. And we want to move that 2 to the left to make it a decimal and no longer a percentage so that we can work with it using our multiplication or whatever operation we need to do. So 360 times 0.32 is 115.2 degrees. Now most likely they'll want you to round to the nearest whole number on something like this, so probably your answer would be 115 degrees. It's possible they want it to the nearest tenth, which means we leave it exactly like it is. Or if it wanted it even to the nearest 100th, we would have needed more decimals and we would use 2 decimal places. So it just depends on how they want you to approximate it. So next they talked about the circumference of a circle. The circumference is the outside length of the circle. If you were to walk around the outside of the circle and measure how long that took, that would be your circumference. They also told us that AB was 22 centimeters. So from A to B is 22 centimeters. And A to B, you'll notice, is a diameter on this circle. It goes all the way across. So when we're finding circumference, there are 2 formulas, depending on whether you're given the radius or the diameter. C equals 2 pi r, or C equals pi times diameter. In this particular case, we're given diameter, so we're going to use the pi times diameter formula. So we're going to replace the letter D with 22. Now even though it's not written, really we're multiplying there. So pi times 22. Now we have 2 options for how the answer is going to be written. Sometimes they will ask us to leave it in terms of pi. So we'd literally just write the 22 first and put the pi next to it. 22 pi would be our answer if it's written in terms of pi. The second is they may want you to approximate it, and usually they'll specify to approximate it using 3.14 as pi. So if we multiply this together now, 22 times 3.14 is 69.08. So this is approximately 69.08. Now again, it depends on what decimal place they ask you to approximate it to. If it's to the tenths place, we would round this up. The 0 could either stay a 0 or round up to a 1. And in this case it would round up because the number next to it is bigger than 5. So then we have one last type of problem. That's finding the length of just a small piece of the circle. If you're doing the entire circumference, you use that formula 2 pi r or that formula pi d. If you're doing what's called arc length, you're going to use the formula theta over 360. They may not have used the symbol theta. This just means the angle measure of the arc. It's a Greek letter commonly used to represent an arc. So theta over 360 times 2 pi r. And technically we could do 2 separate formulas. We could say theta over 360 times pi d, and that would also work. You're just basically saying the angle divided by 360 times the circumference. But I usually just like to stick with one so I don't have to remember so many different formulas. So, angle, well, we're looking at arc BC, and they didn't give us an angle measure of the central angle that goes with it. But we discussed earlier, if it's on a straight line or it's part of a semicircle, we can just do 180 minus 145 to get that arc measure. So 180 minus 145 is 35 degrees. So that is our angle measure of the arc we're trying to work with, times 2 times pi times r. Well, they gave us diameter again, A all the way to C. It's pretty easy to find circumference from diameter to or sorry, to find radius from diameter, because that's what we need to plug into that circumference. Radius is just halfway across the circle instead of all the way across. So we just divide 12 by 2, and that gives us a radius of 6. So again, it depends on if they ask you to find this in terms of pi or ask you to approximate. If it asks you to find this in terms of pi, we would just do everything else and ignore the pi. 35 divided by 360 times 2 times 6. All put together, that would give us 7 over 6. So in the case of one like this, they're probably not going to ask you to leave it when it's a fraction. It would probably come out as like 5 pi or 18 pi, a nicer number. So this one is more likely going to be asked to be solved as an approximation, which means we would just change pi to be 3.14. If it doesn't specify 3.14, but asks you to approximate, I would use a few more digits of pi. I would use 3.14159. That way you'll get closer to the answer they really want. And I know it seems like it's not a huge difference to put those extra digits on, but it can be. If they specify use 3.14, don't use them because your answer might be a little off from what they're expecting. So it depends on if they specify 3.14 only, or if they just say approximate pi. So multiplying this now by 3.14159, and we get approximately 3.665, or again, they're probably going to want you to go to the tenths place, so 3.7. And that covers our discussion of circles and arcs.